So today we are going to see about the simulation of capacitive load. So here a capacitive load or capacitance or a capacitive load is connected in parallel with the AC source. So here this capacitor will withdraw a current which leads the voltage by 90 degree. So this is theoretically proven, and we are going to check this with the simulated model. Before that, I show you the waveforms, and this is the current voltage applied to the capacitive circuit or a capacitor load, and this violet color indicates the power drawn by the circuit, and this red color indicates the current. And here you see that the current waveform leads the voltage by 90 degree, and here can see the diagram. So here Vm is there, and this Im leads the voltage by voltage by 90 degree. So it leads the voltage by 90 degree. So this is going to check in the simulating model, and here the MATLAB is there, and by using that MATLAB we can simulate the concept. So here I am going to open a Simulink model in order to create the circuit, and this is the untitled Simulink model, and here library is there to access the components whatever we need for the for simulating the circuits. So in this circuit we need three components. One is voltage source and another one is a capacitor. These two components are needed. Additionally, we need current measurement block and voltage measurements blocks. So I am going to simulate that same circuit here. So that's are available in the Simulink library, and here you can find the electrical source under the fundamental blocks category, and here the voltage source is available. You can add it into the untitled model, and another components, C components, that is capacitive element is needed. So you can choose RLC series branch. I added two components, one is voltage source and another one is a RLC series branch components, and I need a scope to measure the input voltages and to see the waveforms. So for that I need a scope that is available under the sinks option. So you can add this into the model, and another measurement tools are needed. That is, one is current measurement and another one is voltage measurements. So these two are needed, so it is also added with the Simulink model. So now we can come to the model, and the added components are shown in this window. So here you see that I am connecting the elements with the circuits. So the current measurement should be connected in series with the components, series with the voltage source and a capacitor. So now I am enabling only the capacitive option. So here 1 microfarad is selected. So I am increasing this to 10 microfarad. Okay, and I am applying it as that value, and now the circuit is almost ready, and now I am connecting a voltage source in order to see the voltage waveform, in order to see the voltage across the capacitor. And I need two input source scope, so I am changing the setting of this scope, and I am selecting two input source. I am modifying the number of input ports by 2. So it is default, it will be 1, and I am changing it to 2. So now you can see the two input ports, and you can connect that ports into the voltage and current measurement block. And here I am not fixed the voltage magnitude, it is defaultly 100, so we can keep the same or we can change it. And I am changing the frequency of this input source as 50 Hz. And now I need a power guide to run this Simulink model block. So it is available in the fundamental blocks option, and you can add it into the Simulink model. So it is also added, and now you can change it to simulation type as a discrete, and it is defaultly it is showing 50 microseconds. That is enough for this simulation, and you can limit the running time of the simulation. So you can keep it as 1 or we can keep it as 2. So that decides the running period of the simulation. So now you run this. So here these two are not able to connect in parallel with each other, so you can add a small resistors, even it may be in a 0.001 ohm, so you can add it. Now you run the program. So now the simulation ran. So now you can see the waveforms. So here the voltage current magnitude is very large, and here the two waveforms are shown. One is voltage and another one is the current. So the two waveforms are there. One is voltage and another one is the current. So now we can reduce that magnitude by increasing the value of the inductance. So I can give 50 millihenry to reduce the magnitude of the current, and if you are reducing that value, so the current may increase. So now you see that the magnitude of the current is decreased when I am increasing the value of inductors. And then again you can see the waveform. Now I am decreasing the value of the inductance from 50 millihenry to 50 millihenry to 25 millihenry, and now you can see that there is a waveform, and it is showing the graph between the voltage and current. Now you see that the current lags the voltage by some angle, and now I am going to change this as a capacitive load. Okay, RC component, and now 10 microfarad capacitor is connected. Now you check the phase angle difference. So now I simulated two different kinds of circuits. One is with the help of inductance, and another is with the help of the capacitance. So we can reduce that magnitude, or we can increase the value of the capacitors or decrease the value of capacitors in order to get a different range of currents. Okay, so you see here the reducing of the capacitance is reducing the current. So I am adding more capacitors, that is 1000 microfarad with the circuits. So now you see that there is a huge variations in the waveform, and now we can enlarge the x-axis to see the waveform very clearly. You see here, now the voltage and currents are having some phase angle difference. The current leads the voltage by 90 degree. Okay, so here you see here the current leads the voltage by 90 degree. So this is the difference in the phase angle. Okay, so here I shown you two simulation. One is inductive and another one is capacitive. So in the inductive, the current lags the voltage by 90 degree. In the capacitive circuits, the current leads the voltage by 90 degree. So that is the difference. Thank you.